Have you ever wondered how a motherboard, the heart of your computer, is made? Yes, the motherboard, that large flat piece of tech that's home to the brain of your computer, the central processing unit or CPU. It's the grand central station of your computer where all information passes through. It's a marvel of modern technology, complex yet elegantly simple in its purpose. The motherboard is critical to your computer's function. It's responsible for coordinating and connecting all the different hardware components that make up your computer. These include the CPU, memory or RAM, hard drives, and other peripherals. The motherboard ensures these components communicate effectively with each other, enabling your computer to function smoothly. But how does this essential piece of computer hardware come to be? How is it that a collection of circuits, chips, and connectors can all come together to form this technological marvel? It's a fascinating process, one that requires precision, patience, and a deep understanding of the inner workings of computers. Motherboard manufacturing is a complex process that involves several stages. It starts with the design of the motherboard, where engineers create a blueprint that outlines where each component will go. This blueprint is then used to manufacture the printed circuit board, or PCB, which forms the base of the motherboard. Once the PCB is made, the various components of the motherboard are attached. These include the CPU socket, memory slots, and various connectors for peripherals. Each component must be placed precisely and securely to ensure the motherboard functions correctly. The final stage of motherboard manufacturing involves testing and quality assurance. Each motherboard is thoroughly tested to ensure it functions correctly and meets the highest standards of quality. This is just a snapshot of the process. There are many more intricacies involved, each requiring a level of expertise and precision that's truly mind-boggling. So, buckle up as we take a journey through the intricate process of manufacturing a motherboard. Every masterpiece starts with a blueprint, and motherboards are no exception. The creation of a motherboard begins in the virtual world long before it takes physical form. Engineers use advanced computer-aided design, or CAD software, to outline every minute detail of the motherboard. Imagine designing a complex city with roads, buildings, and infrastructure. That's what it's like to design a motherboard. The engineers must consider the placement of each component, ensuring they will all fit together seamlessly. Just like in a city, traffic flow is crucial. They must plan for the smooth flow of data, avoiding any bottlenecks that could slow down the system. Precision is paramount in this step. A single misstep could lead to a faulty product, wasted resources, or even worse, a system failure. Every millimeter counts, every pathway matters. With a precise and carefully planned blueprint, the real work begins. The heart of the motherboard, the printed circuit board, or PCB, is born from a simple piece of fiberglass. This unassuming material is about to embark on a transformative journey that will endow it with the ability to support a universe of digital interactions. The process starts with the coating of the fiberglass with a layer of copper. This copper coating isn't just a fancy dress, it's the precursor to the intricate network of circuits that will soon crisscross the board. This copper layer is applied uniformly across the entire surface of the fiberglass, creating a shiny, metallic canvas upon which our circuit design will soon be etched. Once the copper coating is in place, the real magic begins. Armed with the blueprint designed in the previous stage, a high-precision machine begins to etch away the unnecessary copper. This process is akin to carving a sculpture, where the artist chisels away the excess material to reveal the masterpiece within. Here, the machine carefully removes copper, leaving behind a complex maze of pathways that will guide the flow of electricity across the board. The precision required at this stage is mind-boggling, as even the slightest error can lead to a faulty circuit, rendering the entire board useless. The importance of this step in the manufacturing process cannot be overstated. The etching process is the first time that the digital design becomes a physical reality. It's the point where the abstract concepts of electrical engineering take on a tangible form. It's the moment when the motherboard begins to take shape, setting the stage for the rest of the manufacturing process. After the etching process, the board is washed thoroughly to remove any remaining copper particles. It is then inspected meticulously for any defects or errors. This rigorous quality control ensures that every single PCB that makes it through this stage is ready for the next step in its journey. Once the PCB is ready, it's time to get to the heart of the matter, the components. The stage is set, the pathways are etched, and the motherboard is ready to come alive. But that's a story for another time. For now, let's marvel at the humble PCB, the silent hero that makes our digital world possible. With the PCB ready, it's time to bring the motherboard to life by attaching the components. The heart of this process is the installment of various critical components onto the PCB. These components include the CPU socket, RAM slots, expansion slots, and more. Each of these components plays a pivotal role in the functionality of the motherboard, and therefore in the overall performance of your computer. First off, let's talk about the CPU socket. This is where the brain of your computer, the central processing unit or CPU, will be housed. The CPU socket is carefully soldered onto the PCB, a process that requires absolute precision to ensure proper connectivity and functionality. Next up are the RAM slots. The random access memory, or RAM, is essentially your computer's short-term memory. The more RAM slots you have, the more memory your computer can utilize, leading to faster and smoother performance. These slots are also meticulously soldered onto the PCB. Then we have the expansion slots. These are your gateways to upgradability, allowing you to add more components like graphics cards, sound cards, or network cards to enhance your computer's capabilities. These slots too are soldered onto the PCB with the utmost precision. But how is this level of precision attained, you ask? Well, thanks to the marvels of modern technology, this process is largely automated. Specialized machines are used to pick and place these components onto the PCB. These machines are capable of incredible accuracy and speed, ensuring that each component is perfectly positioned and securely attached. Once all the components are in place, the motherboard is passed through a reflow soldering machine. This machine melts the solder paste that was applied earlier, forming a solid electrical connection between the components and the PCB. So, there you have it. A fully assembled motherboard, ready to be the backbone of a computer. But we're not done just yet. Now that the components are in place, it's time to ensure everything works as it should. Quality assurance is a critical step in the manufacturing process of a motherboard. This is where we ensure that the motherboard is not just a piece of art, but a masterpiece that performs as beautifully as it looks. After the components have been attached, the motherboard undergoes a series of tests. The first is the power on test. This is where we check if the motherboard is alive, if it's breathing, and if it's ready to take on the world. We power up the motherboard to see if it responds correctly. It's like the first cry of a baby telling us it's ready to take on life's challenges. Next, we perform functionality tests. This is where we check if each component on the motherboard is functioning as expected. It's like the first steps of a toddler where we check if it's ready to explore the world on its own. We test the sockets, the ports, the connections, everything to ensure that they are functioning as intended. Then comes the stress test. It's like the teenage years of a motherboard where we push its boundaries and see how it performs under pressure. We simulate extreme conditions, like high temperatures and heavy loads, to see if the motherboard can handle the stress. This test ensures the reliability and durability of the motherboard. It's like a rite of passage, confirming that the motherboard is ready to face the real world. Finally, we perform a burn-in test. This is where we run the motherboard continuously for a certain period. It's like the final exam before graduation, where we check if the motherboard can perform consistently over time. These tests are not just procedures, they are the rites of passage that every motherboard must go through to prove its worth. They ensure that the motherboard is reliable, durable, and ready to take on the role of being the heart of a computer system. With the tests completed successfully, the motherboard is ready to be the heart of a computer system. From a piece of fiberglass to a functioning motherboard, the journey is a complex one. We began with the birth of a motherboard, a simple yet fundamental piece of fiberglass, and then moved on to the intricate process of designing the blueprint. That's where our craftsmen plan, design, and prepare for the adventure ahead. Next, we dove into the manufacturing of the PCB, an intricate dance of etching and drilling where precision is key. Our journey then took us to the attachment of components, a meticulous process of soldering and mounting that brings our motherboard to life. Finally, we explored the rigorous testing and quality assurance process, where every motherboard is put through its paces to ensure it's up to scratch. Each step is vital, each process demanding exactness and precision. So, the next time you use your computer, remember the intricate process that went into creating its heart, the motherboard.